Okay. So we're on page 23 in the copy of the reading that I sent out in our email. So we're starting with the water cycle. The water cycle. You read the amount of water on Earth does not change. The water that you drink has been on Earth for a long time. Millions of years ago, a dinosaur might have swallowed the same water that you are drinking today. Or that water might have raged down a river, flooding an ancient city. How does water move from place to place as time passes? The water cycle is the continuous movement of water on, above, and below Earth's surface. The sun provides the energy that drives the water cycle and moves water from place to place. As this occurs, water can change state to a gas or a solid, and then back again to a liquid. The change of state requires either an input or an output of thermal energy. Figure 10 illustrates how energy is absorbed during evaporation and released during condensation. Because the water cycle is continuous, there is no beginning or end. Water continually moves through all of Earth's systems. So we're going to freeze there. Yes? What? Okay. And we're going to go to our notes. All right, so the water cycle is the continuous movement of water on, above, and below Earth's surface. Do you guys know the aliens from Toy Story? Mm-hmm. And they're like the claw, right? And the things like the claw is like, yeah. So whenever when I say the sun, I think of it like the same way, because the sun is what provides life for us on Earth. So I always say the sun. So the sun provides the energy that drives the water cycle. The sun. The sun provides the energy that drives the water cycle and moves water from place to place. As this occurs, water can change state to a gas or a liquid, or a gas or a solid, and then back again to a liquid. The change of state requires either an input or output, so either adding or output, meaning like giving back of thermal energy, also known as heat. Thermal energy, also known as heat. That's why like a thermometer measures heat, right? Or a thermostat controls the heat in your house. Or if you're from up north or ever have been in snow, they tell you to wear thermal pajamas underneath to keep the heat in. Because you've been in the mountains, right? Oh, I love thermals. Because the water cycle is continuous, there is no beginning or end. Water constantly moves through all of Earth's systems. It is a cycle. It's ongoing. There is no start time, end time. It's all happening at the same time. This one is huge. The idea that there is no beginning or end. It's always happening. Now I think because we're recording it, I'm going to read the whole thing so that it's on the recording. and we can just make sure we're following along, okay? All right, so thumbs up when we're good. Draco, we good? Awesome. All right, so I'm going back. All right, evaporation. Evaporation. When the sun shines on an ocean, water near the surface absorbs thermal energy and becomes warmer. As a molecule of water absorbs thermal energy, it begins to vibrate faster. When it has enough energy, it breaks away from the other water molecules in the ocean. It rises into the atmosphere as a molecule of gas called water vapor. Evaporation is the process by which a liquid, such as water, changes into a gas. Water vapor, like other gases in the atmosphere, is invisible. You guys see a word maybe in the word evaporation that might indicate that it turns into a gas? Helen? Vapor, right. In the word evaporation, it has the word vapor. That tells you it's going to end as a gas. It turns from a liquid, that's bad, liquid to a gas. It ends as a vapor. Get it? E ends as a vapor. When the sun shines on an ocean, water near the surface absorbs, call it out. What should I write? It absorbs thermal energy. Perfect. Thermal energy and becomes warmer. As a molecule of water absorbs thermal energy, it begins to vibrate. Faster. All right, everybody freeze where you're at. Put your hands together. Rub them together slow. Slow. You feel some vibration, right? It's warm, but it's not crazy warm. Go faster. What do you notice? It's getting really hot. Notice fast. The faster the molecules move, the faster they get, the warmer they get. Right? The faster you go, the warmer they get. When the faster that those molecules move, the warmer they get. When they get enough thermal energy, and they get hot enough, they break away from other water molecules in the ocean, and it rises into the atmosphere as a molecule of gas called water vapor. Evaporation is the process by which a liquid, such as water, turns into a gas. Well, a molecule in its liquid form, because it's talking about whether it's a what state of matter that molecule is in. That's okay. I'm not going anywhere. I am going to highlight something though. Why does it rain a lot in Florida? Kyle? Okay, it's humid. What does that mean? What does it mean that it's humid? Hot and humid are different. What does the word humid mean?
I know.
Go ahead, Andrew.
Like a lot of moisture.
Yes, there's a lot of moisture in the air.
Wet and hot.
So humidity has to do with the amount of water vapor in the air. Why is it so humid in Florida then? Why is it more humid in Florida than it is in Kansas? Brian.
Because
It can evaporate more water. Where's the water coming from? Shiloh. Right. How many sides, Joel, how many sides of Florida are surrounded by water? 3, right? We're a peninsula. So The fact that we're surrounded by water, the fact that we're surrounded by water on 3 sides means we're picking up a lot of water all the time. Possibly. Yes, Joel.
Because we're closer to the equator.
So we have higher temperatures, and listen, guys, we have higher temperatures because we're closer to the equator. Those higher temperatures make the water in the oceans do what?
Like create hurricanes.
What does it make? The hotter temperatures make. Yep, the hotter temperatures make the water on the coast evaporate. Then it's stuck in the air, right? As it rises, because all that water from the coast is in the air, as it rises, it ends up forming clouds and precipitating. That's why it rains so much in the summertime, because it's hotter, right? I know. It was raining. It was pouring this morning. Yes. And you can see it because it's cold outside, but it's still rising. It like looks like a cloud on our surface. Yeah. So I want you guys to write this. Florida has a lot of rain, because this is important, especially because we live it, right? It has a lot of rain because that's what that B/C means. Because it's on the coast, or I'll say because it's a peninsula. We'll use better words. It's a peninsula and evaporates a lot of ocean water. B/C means because. B/C means because. It's shorthand. That's super important, guys. Especially because we live it, right? I lived on the coast up in Maryland. I lived right on the Chesapeake Bay. It did not rain nearly as much. Why would it not rain as much in Maryland if I lived on the, even though I still lived, raise your hand, I still lived on the coast. But why would it not rain as much, Diego? Why is there not as much water evaporating? Okay, so I'm not surrounded by water on 3 sides, but why else? Think about where Maryland is, Joel. There's still the same amount of sun. Don't think, what else does the sun give off that causes evaporation? Heat, right? It's colder up there. It's further from the equator. So it's not as hot to evaporate all of that water, right? So number one, you're only surrounded by water on 1 side instead of 3. And number 2, it's colder out there. Oh, yeah?
I don't get this because Washington is hot.
Washington State?
Yeah, Washington State is hot, but it's not near the equator.
Washington State isn't hot.
Yes, it is. Kansas is like 60 all the time.
It's not hot. It's not hot like Florida's hot.
Yeah.
Washington.
But we're not hot, we're humid.
Well, humidity is a result of heat mixed with water vapor. Humidity is a result of all of that water being picked up and then staying in the air.
Oh.
So Washington is not hot. It's rainy, but it's not humid like it is here because the water vapor doesn't stay in the air. It does rain a lot there though, in Oregon and Washington. Mm-hmm. All right. We also a lot of our storms, the wind will come from the west, right? And then we also get stuff from the southeast. That's why there's a lot of tornadoes that happen in the middle of the United States, because they get cold weather that comes from the northwest, right? And then we get warm weather that comes from the southeast, and they meet in the middle and create a funnel. That's why Tornado Alley is in the center of the United States. Yes, Landry.
Why are we called the sunshine state? There's never sunshine.
Good question. We should call ourselves
The rainy state.
the rainy state or the hurricane capital.
Sad state.
All right. So I'm going to move on to transpiration and respiration. Make sure we're following along. We're not going ahead because there may be something that I say that might make sense to you. All right, here we go.
Wait, Miss Burley,
Yes.
would it be okay if I have the passage printed out?
Absolutely. That's a smart idea. That's why I email it to you ahead of time. I'm only reading it out loud because I'm recording this one. So it may be helpful to anybody who's at home and watching it.
Okay.
So transpiration and respiration. Oceans hold most of Earth's water, so they are major sources of water vapor. But water also evaporates from rivers, lakes, and puddles, and even soil. These sources, along with oceans, account for 90% of the water that enters the atmosphere. Most of the remaining 10% is produced by transpiration. Transpiration is the process by which plants release water vapor through their leaves. Some water vapor also comes from organisms through cellular respiration. Cellular respiration takes place in many cells. Water and carbon dioxide are produced during cellular respiration. When animals breathe, they release carbon dioxide and water vapor from their lungs into the atmosphere. The blue arrows in figure 11 show how water vapor enters the atmosphere. Does anybody know what perspiration is? What perspiration is, Maddox?
The release of water from the organism of plant.
Yes. So I have a trick to show you. When a person sweats, it's called perspiration. Write this at the bottom for me. When a person sweats, or releases water.
So that's the only way we can release it.
I'm talking. Just listen, right? Perspiration is when a person sweats. When a tree sweats, it's transpiration.
Miss Burley, I have a question.
Yes.
Is sweat just water?
It's water and salt.
Okay.
And trees don't actually sweat, guys, but I was just trying to get you to understand that when we release water from our skin, that's called perspiration. When trees release water through their leaves, it's called transpiration. So it's a way to help you remember what that means. Condensation. I know. Does that help? That idea of using that trick, transpiration in trees?
Yes, it does help.
Good. So oceans hold most of the Earth's water. So they are major sources of water vapor. Water vapor. But water also evaporates from rivers, puddles, lakes, and even soil. That's why I have to continuously water my plants. These sources, it should say alone, with oceans, account for 90% of the water. But that remaining 10% is made by plants. Transpiration. Yep. These tricks, they help. I hope that they help. But you always have to find a way to make it make sense. How many of you knew what transpiration was before today? Transpiration. But now do you feel like because of understanding that it's when like a tree sweats? Good. Who is it? Okay. Let's try to finish this before lunch comes. Okay? So stay super focused, and then you guys can eat when the Bill and I come. I also want you to know that oceans hold most of the Earth's water. Yes, love.
All right. So like that, how are lakes made? Like, when did like the soil get dumped
Lakes. Some lakes are man-made, and then some other lakes are just made by erosion and
Erosion's when it moves.
moves. Correct. So some water vapor also comes from organisms using through cellular respiration. What does it mean to respirate? Think about it. What is respiration?
I know.
What is it? What is it, Andrew?
To breathe or like,
Yes. It's when cells breathe. All living things need to breathe. Cellular respiration takes place in many cells. We're made up of trillions of cells. Water and carbon dioxide are produced during cellular respiration. When animals breathe, they release carbon dioxide and water vapor from their lungs into the atmosphere. You'll learn more about that when we talk about cells in Unit 5. Yes?
On the first page also has 3 words.
Transpiration. Transpiration is the process by which plants release water vapor through their leaves. Thumbs up when we're ready to move to condensation. Condensation nation.
Okay, yeah.
What does it mean to condense something? What does it mean to condense something? Okay, so what'd you say? Put it together?
When you leave something out that's cold, and then when it gets warmer, it's
Okay.
like
So when the water droplets come together? When something comes together, right? So the word condense means to come together. It means to make something that's very big, small. I want you to know before we start reading that the troposphere is the lowest layer of the atmosphere. We haven't learned that yet, but we'll learn it this unit. So where it says temperatures in the troposphere, they mean the lowest level of the atmosphere.
the hottest.
Not the ground. The ground is considered the lithosphere.
No.
All right, I'm going back to the reading. All right, here we go. So we're reading about condensation, and we'll do precipitation at the same time. Oops, that's not what I want to do. All right, here we go. Recall that temperatures in the troposphere, so in our lowest layer of the atmosphere, decrease with altitude. So as water vapor rises through the troposphere, it becomes cooler. Eventually, it loses so much thermal energy that it returns to the liquid state. The process by which a gas changes to a liquid is condensation. Tiny droplets of liquid water join or condense, right, to form larger drops. When millions of water droplets come together, a cloud forms. Precipitation. Eventually, drops of water in the clouds become so large and heavy that they fall to Earth's surface. Moisture that falls from the clouds to Earth's surface is precipitation. Rain and snow are both forms of precipitation. More than 75% of precipitation falls into the ocean, and the rest falls onto land. Some of this water evaporates and goes right back into the atmosphere. Some flows into lakes and rivers, and the rest seeps into soil and rocks. In the water cycle, water continually moves between the hydrosphere, the cryosphere, the atmosphere, the biosphere, and the geosphere. As water flows across the land, it interacts with soil and rocks in the geosphere, which we're going to talk about next week. So we're almost done with the reading part. We're going back. So I want you guys to help me fill in the blanks. Temperatures in the troposphere, blank with blank. Look at the reading. Chinta. Decrease with altitude. How many of you have ever seen a mountain and at the top of the mountains it's snowing and at the bottom there's trees that aren't covered in snow? Or how many of you have ever realized that at the top of a mountain it's colder than it is at the bottom of the mountain? Yeah?
when I went to Colorado, we climbed the mountain, and we had to use a little canned oxygen thingy, and it got.
I want to see some. Oops, that's not what
Wherever I go, the snow is usually all over space snow.
Let me see if I can find it. Hold up, look. I want to show you something. So I was in Colorado too over the summer, and when I saw the mountains, it's hard to see, but in the picture, so this is where I'm at, and at the top, some of the mountains you can see snow. Look far back. You see the snow at the top of the mountain?
Yeah.
So where I am,
Yes.
look, I was in Denver, Colorado. I'm just chilling on a rock, right? It's still higher altitude. So in all the pictures I took, I was wearing like a jacket, right? Because it was colder. But if you look really close, look, no snow down here, right? But if you look super close at the ones in the distance, which means if they're further in the distance, it means they're that tall. Like, look how tall they are, but they're further away. So that means they're really tall, right?
Mm-hmm.
Look close. See all the snow? Fancy!
Is Colorado fun?
Colorado was so much fun.
I
Huh?
want to go to Colorado so bad.
Bathroom place, because I went to Denver and
No, that was just on the side of the road.
I just want to go anywhere except for
So I
Florida.
want you guys to think of, when you see this, I want you guys to think of the picture that I showed you where there was just regular rocks. And here's Miss Burley throwing up a peace sign. Right? There's my peace signs. And there's no snow down here. But up here, it was all covered in snow. So as water vapor rises through the troposphere, it becomes cooler. Eventually, it loses so much thermal energy or heat that it returns to the liquid state. Cold. The process by which a gas changes to a liquid is called condensation. All right, so listen to this. Did you guys hold up? Can you wait? Can you wait? I'll wait. You guys know that gases have no set volume, right? That's why Cody can delta it and I smelt it. Because a gas has no volume. But a liquid has a defined volume. If I were to pour a liquid in a glass, it's going to stay in the glass, right? If I tube, it's going to go all over the room. Delta it, smelt it, right? So when it condenses, then it comes together, so it has a set volume again. Does that make sense? Okay. Really quick, raise your hand if you want lunch. Just raise your hand. Does anybody in here buy lunch? Okay. Nobody bought lunch? Order. No, Emmanuel did. Okay, that works fine. All right. Tiny droplets of liquid join to form larger droplets. When millions of water droplets come together, what forms?
Condensation.
What does condensation form? Look at the book, guys. A cloud.
Oh.
I have another trick to show you. Condensation, the C stands for cloud. The C in condensation stands for cloud. Look at that.
Miss Burley,
Yes?
I went to West Virginia once so I can go skiing, and then we had to drive all the way up a mountain, and then it was 10 times colder up there.
It is, because as altitude goes up, there's less oxygen available.
Did you get that?
Yep.
Miss Burley,
Yes.
I once went to a vacation for my dad's birthday in Canada, and we lived in the mountains for a little bit.
Was it cold?
Very.
So I want you guys to write that higher up means that it's going to be colder. If it's higher up, it's going to be colder. That temperatures decrease with altitude, that's important for us to know. And then the definition that the process by which a gas changes to a liquid is condensation. Almost done, y'all. Almost done. Thumbs up when we're ready. Awesome, here we go. Precipitation. Eventually, drops of water in the clouds become so large and heavy that they fall to Earth's surface. Moisture, very good, that falls from the clouds to Earth's surface is precipitation. Brian, give me one form of precipitation. Snow. Leon, give me another form of precipitation.
Water.
Well, water in what form?
Rain.
Rain. Give me another one, Andrew.
Hail.
Hail. And what's the one that's a mix of snow and rain? Allison. Sleet. I said Allison, and my whole class must be named Allison. More than 75% of precipitation falls into the ocean, and the rest falls onto land. Some of the water evaporates and goes right back into the atmosphere. Awesome. Some flows into lakes and rivers, and the rest seeps into soil and rocks. That must be why Clementine eats rocks. She must be thirsty. My dog, the puppy, she like eats rocks all the time. I don't know how. I don't know, man. No, it means that she needs some nutrients. It's also a puppy thing. Oh yeah, I could try that. Well, I asked the vet, and the vet said it's also because she's teething, so she just wants something hard to chew on. So we gave her a bone that's hard, to help her teeth, and a leather toy to help her teeth. But that's a good idea. I should try that. All right, so I want to talk to you guys about these words. I'll wait, because you do need to know this. We know what the atmosphere is, which is what? What is atmosphere? What is that?
The thing that divides space and
What is it filled with, though? Gas, air. What is the hydrosphere then? What does hydro mean? Hydro flasks. What does that mean? What does hydro mean? Water. What does the biosphere mean? Raise your hand. What does bio mean?
life.
Life? I said raise your hand. You guys don't know this one yet, but I will share it with you. Does anybody know what the cryosphere is?
Round.
All right, let's guess, Kyle. Nope, that's geosphere. I'll show you. Just wait.
Is it like a freezing chamber or something?
Yes, good job, Andrew. What made you think of that?
Because this is a really dumb reason, but I play a game where you can tame animals, and if you get a cryo fridge, you can put your animals in that fridge and inside a ball, and they'll keep them.
That's not dumb, because the way I teach it in two ways. The first way I teach it is, if you've ever seen Captain America, they put him in a cryo chamber, and the cryo chamber is filled with
Gas, like cold
ice.
air. Ice.
Maybe. So watch. I have a couple ways. I'll wait. For you to remember, atmo means air. Bio means What is bio?
Life. Geo.
What is geo? Who
Rocks?
said that?
Ground or rock. Yep. And hydro. Water. Watch this. So cryo is ice, and I remember it as ice, like ice, ice, baby. And what do babies do? They cry.
Cry. That's smart.
Get it? Ice, ice, baby. What do babies do? They cry. So let's highlight our important stuff, y'all. We've got our definition for precipitation. This is when moisture falls. And then I want us to also know that water continually moves between all of these spheres on Earth, which we'll practice more with next week. My atmo is air, bio is life, cryo is ice, ice baby, geo is rock, and hydro is water.
I don't know, but he got confused.